Alright, this is my problem 46, the second video for the week 8 video explainers. So in this problem, we have two wires that are tied to a 300-gram sphere, and this sphere is moving in a horizontal circle at a constant speed of 7.5 meters per second around a pole, and we're trying to figure out the tension in each of these wires. So just quickly draw out a diagram, and we can see that the ball is moving in a counterclockwise direction. The length of the wires are both a meter, and for the hypotenuse, and then the other length is going to be 0.5. Later we're going to be able to find that other side length, and the ball is moving at a constant velocity, as we already covered, and it's 300 grams. So by separating this into x components and y components, or horizontal and vertical directions, we can figure out what the respective tensions are for each of the wires. So as we know from Newton's second law, the net force is going to be equal to the mass times the velocity squared over r, so that the distance, effectively the distance from the object to the center of rotation. So first started off in the x direction. So the tension 1 times cosine theta plus tension 2 cosine theta is going to be equal to mass velocity squared over r. And we can take out cosine theta and move it over to the other side just to kind of simplify it, because later we're going to be solving a system of equations, and that's going to make it easier for us to find the tensions for the first and second wire. So now in the vertical axis, in the y direction, we know that the net force is going to be 0, because earlier it was moving in a horizontal circle stated in the problem. So that equation is going to be kind of similar to the first one. However, it's going to be equal to the forces in the that y direction, which is going to be the tension sine theta of the first wire minus the tension of the second wire, minus the mass times the gravitational constant, and that's going to equal to 0. So when we move mg over in sine theta, the same step we did as before, we're going to get the tension of the first wire minus the tension of the second wire is going to equal to mg over sine theta. So we're going to need that r value, the distance from the ball to the center of rotation, and that's just going to be using Pythagorean theorem to get 0.866 meters. And now we're going to solve essentially a system of rotations. So in the x direction, I noted here T1 plus T2, that's going to be the mass of 0.3 kilograms times 7.5, which is the constant velocity in the x direction, over that distance r times cosine 30, because it's in the x direction. That's going to equal to 22.5 newtons. And then in the y direction, that's going to be the tension of the first minus the tension of the second. So similarly, the same mass. However, because it's going to be in the y direction, it's not going to have that constant velocity in the x direction. So that is actually just going to be the gravitational constant of 9.8 meters per second squared, and then sine 30, because it's in the y direction, and that's going to equal to 5.88. Now we just have a system of equations. So we're going to solve for T1, which is going to equal to 22.5, and eventually we're going to find that T2 is going to equal to 8.31, plugging that into the first one, and we can get the values for both tensions. So basically this problem, we're just trying to figure out how to use just more stuff about like objects moving in an orbit, just like centripetal force, all that kind of stuff. And just the hardest part, I guess, here is just knowing how to approach the problem, and I figured out that like drawing a diagram, it always helps, so that you know just, I guess, the necessary steps that you can solve the problem. But yeah, that's going to be it for problem 46.